Hello everyone, welcome to Math is Fun. Our lesson for today is all about powers and exponents. At the end of this lesson, you are expected to write numerical products as powers, write algebraic products as powers, learn negative bases and parentheses, evaluate numerical expressions, and evaluate algebraic expressions. First, we're going to discuss about writing numerical products as powers. For example, 5 times 5 times 5 times 5. And this is the numerical products. The expression 5 times 5 times 5 times 5 can be expressed as power that is using an exponent and a base. So here in this example, we have 4 factors of 5. So the exponent is 4 and this is the power. In the expression 5 raised to the exponent of 4, 5 is the base. What is a base? Base is the common factor that is being multiplied. 4 is the exponent. What is an exponent? Exponent tells how many times the base is used as a factor. 5 raised to the exponent of 4 is the power. What is a power? Power represents the repeated multiplication of a factor. Alright, let's answer some exercises. Write the following numerical expressions into powers. You can pause this video and write your answer in a piece of paper. Okay, the first one, example. 7 times 7 times 7. What is your answer? Yes, you are right. The answer is equal to 7 raised to the exponent of 3. How about this example? 9 times 4 times 4 times 9 times 4. Okay, what is your answer? Yes, you are right. The answer is equal to 4 raised to the exponent of 3 times 9 raised to the exponent of 2. It can also be 9 raised to the exponent of 2 times 4 raised to the exponent of 3. The answer is just the same because of commutative property of multiplication. Another example. Negative 8 times negative 8 times 2/3 times 2/3 times 2/3. What is the answer? Alright, the answer is equal to the quantity of negative 8 raised to the exponent of 2 times the quantity of 2/3 raised to the exponent of 3. Next, we're going to discuss about writing algebraic products as powers. For example, A times B times A times B. So this is the algebraic products. To write this expression into powers, first is we're going to count the factors A and B in our expression. So we have 2 factors of A, so A raised to the exponent of 2 times B. Also, there are 2 factors of B in our expression, so B raised to the exponent of 2. A squared times B squared is the powers. Another example. Write the following algebraic expressions into powers. The first one is 2x times 2x times 2x times 2x. What is your answer? Alright, the answer is equal to the quantity of 2x raised to the exponent of 4. Another example. C times C times 3D times 3D times 3D. What is your answer? Alright, the answer is equal to C raised to the exponent of 2 times the quantity of 3D raised to the exponent of 3. Next, we're going to discuss about negative bases and parentheses. For expressions that contain negative signs and/or parentheses, the inclusion and placement of parentheses can result in distinct expressions that have different values. For example, do you think that the quantity negative a raised to the exponent of b and negative a raised to the exponent of b have the same value? The expression the quantity negative a raised to the exponent of b indicates that negative a is used as a factor b times, while the expression negative a raised to the exponent of b means the opposite of positive a raised to the exponent of b. To fully understand, let's simplify the expressions using values. If a is equal to negative 2 and b is equal to positive 4. So we have the quantity of negative 2 raised to the exponent of 4. Let's make this into a numerical products. So we have negative 2 times negative 2 times negative 2 times negative 2. So let's multiply negative 2 times negative 2. Alright, it is positive 4 times negative 2 is equal to negative 8 times negative 2 is equal to positive 16. And for our second expression, we have negative 2 raised to the exponent of 4. So let's make this into a numerical products. So we have negative times the quantity of 2 times 2 times 2 times 2. And the answer is equal to negative 16. Therefore, the quantity negative a raised to the exponent of b and negative a raised to the exponent of b didn't have the same value. It is because 16 is not equal to negative 16. Next, we're going to discuss about how to evaluate powers. To evaluate an expression with a power, write the power as a product and then multiply. To evaluate the powers, we're going to use the order of operations. So, simplify the expression inside the grouping symbols. Evaluate all powers. Perform multiplication or division in order from left to right. So here, multiplication and division can be interchanged. It depends upon what comes first from left to right. If division comes first, then we're going to divide before we're going to multiply. Lastly, perform addition or subtraction in order from left to right. So, if subtraction comes first before addition, you're going to subtract before you're going to add. Okay, let's study the following examples. Evaluate numerical expressions. So 6 raised to the exponent of 3 plus the quantity negative 2 raised to the exponent of 3. So let's make these expressions into numerical products. So we have 6 times 6 times 6 plus the quantity of negative 2 times the quantity of negative 2 times the quantity of negative 2. So let's simplify. 6 times 6 times 6 is equal to 216 plus negative 2 times negative 2 is equal to positive 4 times negative 2 is equal to negative 8. So negative times positive is equal to negative. So this is negative 8. Then let's subtract. 216 minus 8 is equal to 208. Another example. Evaluate 10 raised to the exponent of 3 divided by the quantity negative 5 raised to the exponent of 2. So we're going to make these expressions into numerical products. So we have 10 times 10 times 10 divided by the quantity negative 5 times the quantity negative 5. So let's simplify. 10 times 10 times 10 is equal to 1,000 divided by negative 5 times negative 5 is equal to positive 25. So 1,000 divided by 25 is equal to 40. Next, we're going to discuss about evaluating algebraic expressions. For example, evaluate a squared minus c squared if a is equal to 6 and c is equal to 4. So first is we're going to substitute the value of a and c into our expression. So we have c squared minus 4 squared. This means that 6 times 6 minus 4 times 4. So let's simplify. 6 times 6 is equal to 36 minus 4 times 4 is equal to 16. 36 minus 16 is equal to 20. And this is our final answer. Okay, another example. Evaluate x cubed plus y squared if x is equal to negative 3 and y is equal to negative 2. So let's substitute the values of x and y into our expression. So we have the quantity of negative 3 raised to the exponent of 3 plus the quantity of negative 2 raised to the exponent of 2. So let's make these powers into numerical products. So we have the quantity negative 3 raised to the exponent of 3. This is equal to the quantity of negative 3 times quantity of negative 3 times the quantity of negative 3 plus the quantity of negative 2 times the quantity of negative 2. So let's simplify. Negative 3 times negative 3 is equal to positive 9 times negative 3 is equal to negative 27 plus negative 2 times negative 2 is equal to positive 4. So negative 27 plus positive 4. So this is unlike sign. We're going to subtract the numbers, then copy the sign of the bigger number. So 27 minus 4 is equal to 23. And the sign of the bigger number is negative. So our answer is equal to negative 23. And this is the value of the expression x cubed plus y squared if x is equal to negative 3 and y is equal to negative 2. I hope that you understand our lesson for today and thank you for watching.